So chapter 3, we start doing a lot more factoring. I don't know if you remember this, but back in chapter 1, there were a few problems that I realized that I had in the homework that you needed to be able to factor to do. And those are the ones that I just took out because I'm like, we haven't talked about factoring. And I know most of you guys probably haven't done factoring for years unless you're coming right out of Math 100. So we're going to review factoring now because in this chapter, we are going to need it. So we're going to review how to do that. And that's an additional lesson that I put in here to help us as we get into chapter 3. Okay, so factoring quadratics is what we're going to be talking about here. And there are some shortcuts we're going to talk about a little bit, but in general, I'm going to teach you one way that will work for pretty much all of these. And that way you don't have to try and learn a bunch of little different things. I will point out a couple shortcuts, but this is where we're going. So factors, first of all, what are factors? Factors are quantities that are multiplied together. So when we talk about factoring, we're trying to break up whatever it is into smaller pieces that are multiplied together to equal the original value. You guys may remember way back in like elementary school, and you would be given a number like 12, and they would say something like, find the prime factorization of 12. And you would start breaking it up, and you'd say, okay, well, I know that 6 times 2 is still equal to 12, right? And then we're done with the 2. You can't break that up any further, but you say, oh, the 6 can break up into 2 and 3. And so we would say that 12 equals 2 times 2 times 3, right? Do you remember doing that way back when, possibly? And that's kind of the idea of what we're going to be doing, but we're going to be doing it with more complicated things than just a 12, unfortunately. So, but that's the idea, to break it up into its little pieces so that when we multiply these little pieces together, we get back to the original. But we want to know what the kind of the ingredients are for that 12. That's kind of the thought process. Okay, what is it made up of? All right, so the first thing we always want to look for, and we're going to look at this in this first example, but the first thing we always want to look for is what is called a greatest common factor. Okay, and I'm actually going to use that idea of prime factors with these two problems to show you kind of what's going on as we look at this. So let me write this down. 3x squared. That means 3 times x times x. And we're not going to do this every time, but again, I want you to see what's going on. But that's 3x squared, right? That's what 3x squared means. Minus, now we just did the 6. How can we break up 6 into its factors? It's 2 and 3, right? 2 and 3. Then we also have an x right there. Okay. Again, I don't expect you to do this every time. I'm just showing you kind of the process that mentally you're going to do. So the idea here is, what do these two terms, each one of these is a term when you have the 3x squared and the negative 6x, each one is a term. What do you see that's in both of the terms? They both have a 3, right? And they both have one x. Does that make sense? So what we're going to do then is we can factor out that 3 and that x from each term. Okay. Now when we look at the first term, and we used to have 3x squared, and we factored out a 3 and an x, what do we have left? Just from this first one. Just the x right here, right? That's all that's left. Okay. Now when we look at the second term and we factored out the 3 and the x, what's left there? The minus 2. Okay. And that is what you're actually doing when you factor out a greatest common factor. Now, one thing I want to make sure I emphasize here is, because we think of this as we're taking it out, what we're really doing, and I will use this term a lot, is we're dividing out the 3 and the x. Because this is actually dividing when we factor this out. And you can realize that if you think about, if you were going to multiply this back out, 3x times x is 3x squared, and 3x times negative 2 is 6x. If you multiplied it back out, well, we're dividing it out to get that 3x out of there. So this is just the reverse of distribution, which we've done previously. Okay, so this would be our answer right here. the 3 times the x minus 2, that's the factorization of this. Okay, now again, I don't expect you to write this all out every time. I just wanted, again, you kind of think about the process of what's going on. So let's take a look at B. And we're not gonna write it all out this time unless I have to. But when I do this, let's think about the numbers first. Is there anything that we can divide out of 8, 6, and 2? All 3 of them. Is there anything that divides in evenly to each of those? And yes, you guys are right. The answer is 2. So we're going to factor out or divide out a 2 from each of those. Now I would look at the x's and I would say, okay, I've got 4 x's here. I've got 3 x's here, and I've got 1 x there. What is in each of them that we can factor out? Just 1 x. This one has 4, so it has an x. This one has 3. But this one only has 1, and that's the one that's limiting us, right? I can't factor out 2 x's because this one doesn't have 2 x's. Okay, so we can factor out 1 x from each of them, and we look at the y's. Y squared, y cubed, y to the 4th. What can we factor out of each of those terms? Look at the y's, the y squared. Okay, now if you want to write that out for now, while you're getting comfortable with it, this is y and y. This is 3 y's. This is 4 y's. Right? I've got 2 here. I've got 2 here. I've got 2 here. That's the most I can take out because this one only has 2. Okay? Now, so that's what we can factor out, or again, divide out. So let's look at the number. If we have 8 and we divide out the 2, what's left? 4, because we're dividing, right? 8 divided by 2 is 4. If we had 4 x's and we divide out 1 of them, how many are left there? 3 x's, x cubed. Okay, if we had y squared and we divided, whoops. You guys are supposed to tell me when I mess up. We factored out y squared, right? If we had y squared right here and we factored out y squared, what's left there? No y's. Technically, it's a 1, but does it make sense? 4x cubed times 1 is still going to be 4x cubed. So we don't have to put anything there for y's. But since we're dividing, it is technically a 1. Okay? Then we go to the next one. If we have a 6 and we're dividing out 2, what number is going to be left there? 3, because we are dividing. If we had x cubed and we're factoring out 1x, what's going to be left there? X squared. And if we had y cubed and we're factoring out y squared, and we can kind of look at the picture here, we had y cubed, we factored out y squared, what's left there? Just a y. Okay, that's the second term. Third term. Now this one you have to be a little careful. We had a -2 and we factored out a 2. What's left there? -1, right? -2 divided by 2 is -1. So that -1 goes there. We had an x and we factored out an x. That's also 1, right? So we've already got the 1. And then we had y to the 4th and we factored out y squared. So what's left there? Y squared. And once we go through that process, factor out and then actually figure out what's left, that's our factorization. Okay, so that is factoring out a greatest common factor. And again, when you're just starting, if you want to break it up and write it down like this so you can see it really clearly, that's totally fine. But the goal is eventually that you can say, okay, I know I'm dividing and I'm just going to divide these pieces out as we go. Okay? But especially if factoring has been a long time ago or you didn't get really good at it when you did it, then, or if this is brand new, it certainly doesn't hurt to write those things out if you want to. So any questions on that before we go on? That's always the first thing we want to look for. Is there a greatest common factor that we can take out? For multiple reasons. First of all, everything that's left here is going to be smaller than what we started with. That's the biggest thing. Okay? And we might be able to do more, but that's the first thing we always want to look for. All right, so this one, maybe looks a little bit tricky, but it's actually just like the ones we were doing if you look at it the right way. So here's what we have to understand. This right here is one term because it's multiplied together. Two factors that are multiplied together. This right here is our second term because it's two things that are multiplied together. What do you see in both of those terms that we can factor out of each of them? The x minus 3. So we're going to factor out the x minus 3 from both of those terms, both of those chunks. Okay? Now, I'm going to put a big bracket here. Not a bracket for interval notation, but a bracket just to hold this stuff together. What's going to be left in this first term after we factor out the x minus 3? The 2x plus 4 is still there, right? That makes sense? So I'm going to put that 2x plus 4 here. And then what's left in the second part after we factor out the x minus 3? The minus 5. Okay? Now, after we see that, are these parentheses, and I made the big brackets, but are these parentheses doing anything anymore compared to that negative 5? It used to be those parentheses were there to show multiplication, right? This times this and this times this. But notice there's no multiplication going on right here anymore. Does that make sense? So these parentheses really become unnecessary. And so now what can we do? Combine like terms. Does that make sense? Because it wasn't multiplied anymore, it was subtraction. So the x minus 3 stays there on the outside in its parentheses. And then here we're going to have 2x minus 1. And so that is the factorization of that thing. Now, you wouldn't normally see something like this. This is actually kind of an in-between step that we're going to create as we do the factoring. But once we create this, then we factor it like this to get this answer. Okay, so we're learning it step by step. Okay. What questions do you have on that example right there? Because you're going to see a whole bunch more like this kind of, but we're going to do it a whole bunch of times. So if you have a question that I can answer now, we will do that. All right. So there's this is one other thing. Remember in multiplication, the order that you write the factors in doesn't matter. 2 times 3 is the same as 3 times 2, right? So this is exactly the same answer as this, even though they're switched around. That makes sense? So the order that you write those factors in doesn't matter. Just make sure they're in parentheses, and then you're fine. All right. So right now, we're going to take another step in the direction that we're going for factoring. And we're going to learn a process called factoring by grouping. So this says factor the following expression by grouping. And grouping can be done if you've got an even number of terms. Okay, now we're going to pretty much limit ourselves to 4 terms. That's when we're going to do factoring by grouping. But it really could be done with 6 or 8 or any even number of terms. Okay, but here's how we do factoring by grouping. We group the first half of the terms together, and then we group the second half of the terms together. And that's why it's called grouping, because we're visualizing them as being in a group. So just looking at these first two, we're going to look for the greatest common factor of these first two. So what do you see? First, think about the numbers 12 and 4. What can you see that can be divided out of both 12 and 4? A 4, right? 4 goes into each of them evenly. So we're going to factor out a 4. And then we've got the n's, n cubed and n squared. What can we factor out of both of those? N squared. Okay. Now, we want to think about what's left. So with the 12 divided by 4 is 3. So that's the number that'll be left there. We had n cubed, and we're dividing by n squared. What does that leave us with? 1n. Does Does that make sense? I think we talked about our rules for exponents or subtraction, right? If you're dividing, you subtract them. So 3 divided by 2, or n cubed divided by n squared, you subtract the exponents, you have 1 left. Okay. And then we've got 4 divided by 4, we know that's 1. And n squared divided by n squared, we know that's 1, right? So that's just 1. And then this is the part that people sometimes mess up on. This thing right here, whatever it is, has to get factored out. In this case, it's a plus, so it doesn't really do anything. But when it's a minus, especially, that's going to be important. Okay. Looking at these, what number can we factor out of both of those? Yeah, 1 you can always, and there's nothing else besides the 1, right? So I'm going to go ahead and put, I'll use green again. I'm going to go ahead and put a 1 here. And are there any n's that we can factor out of both? No. So the only thing we can factor out is a 1, which dividing by 1 doesn't do anything, does it? So this is still going to be 3n plus 1. Now this looks like our last problem that we just did, right? Here's the first big term and the second big term, because now we've split it into 2 big terms. What can we take out of both of those big terms? 3n plus 1. And then what's left is the 4n squared, right? If from this first one, if we factor out the 3n plus 1, the 4n squared is left. And then from the second one, if we factor out the 3n squared, what's left there? Just plus 1. And that's the factorization of this thing using this process of factoring by grouping. Okay. So again, the process we did, we divided into halves. And then we looked at each half individually and factored out what we could from each half. And then we had 2 big groups, 2 big terms, and we factored out the common factor from each of them. And that left us with the common factor and then kind of the leftovers, left over from the first one and left over from the second one. That's what goes in right there. Okay, so after we took out the 3n plus 1, we had the 4n squared. After we took out the 3n plus 1, we had the 1. And that's factoring by grouping. Okay, now again, we're slowly building up. Yeah, and again, the order that you write them in doesn't make any difference. Okay, so we're going to do one more factoring by grouping with the negative in the middle, because that's the one I said tends to mess people up sometimes. Okay, so the first thing is, again, our groups are going to be 5n cubed plus 3n and then minus 10n. Yeah, those 2 that I underlined rather than me trying to say them. Okay, so looking at the first one, what can we factor out of both of those terms? Yeah, there's no number, right? But just 1n can factor out of both of them. Okay, what's left inside the parentheses after we factor out an n from the first term? 5n squared. And then what's left with the second one? A 3? Yep, plus 3. Yeah, we do need the plus sign. And here's where I said a lot of times people mess this up, so I want to make sure I emphasize. We have to factor out that negative. Whatever that sign is, we have to factor it out. Okay? What else can we factor out from these 2 terms? The 2, right? 2 goes into both of them evenly. Now, when we do this, here's where we have to be careful. We are dividing out a negative 2. So negative 10n squared divided by negative 2 is positive 5n squared. Does that make sense? Negative divided by negative is positive. And then negative 6 divided by negative 2 is going to be positive 3. Okay, does that make sense? Okay, and notice again, here's our one big term and our second big term. What is in both of those that we can now factor out? Correct, 5n squared plus 3. And then what's left in the first term after we factor that out? The n. And what's left in the second big term after we factor that out? Minus 2. And so that's our excuse me, that's our factorization. Okay, is that process of factoring by grouping making sense so far? Okay, I'm trying to make it as unscary as possible. Sometimes people hear factoring and they go into panic. Don't want anybody to panic. All right, so what we're going to learn about is factoring quadratics specifically. It works for other things, but we're going to focus on quadratics tonight. And quadratics have this form where the highest power is an x squared or whatever squared. It doesn't have to be x, it could be a different letter. Okay, but there might be a number in the front of this, in front of the x squared, and there might be a number in front of the x, and then a number at the end. Okay, so that's what these are going to look like when we get started. So let's take a look. We're going to use 4 steps to try and factor these. And yeah, the a is not equal to 1, doesn't even matter. Anyway, I should take that out. But the first thing we're going to do is multiply a times c. A is the number in front of the x squared. So whatever that number is, we'll multiply it by c, which is this number at the end. That's the first thing we're going to do. And I'm going to go through these steps a whole bunch of times. You're going to be sick of them by the end of tonight, unfortunately. But hopefully you'll remember them. Second thing, we're going to find the factors of AC, a times c. So numbers that multiply together to be AC that have a sum of b, this middle number. Okay, and we'll see, like I said, we'll see a whole bunch of examples, but this is the process we're going to do each time. Once we do that, then we're going to rewrite our expression with these factors in place of b. So in other words, we're going to take these 3 terms and split them up into 4. And the reason we're going to do that is because we want to use factoring by grouping like we did. And remember, you have to have an even number of terms to do that. So we're going to split those 3 terms into 4 because we're going to split this middle one into 2 parts. Okay, using this information that we just got from step 2. And then after that, we're going to factor by grouping. Okay. And I'm going to take you through some of the thought process. I don't have the thought process on your paper because I have to kind of explain that as I'm thinking through it. But the thought process is going to be kind of important. It'll help us kind of save some time. And those of you in Math 100 who came out of that class, we did this then. So this will be some good review. Okay. Remember to always look for a common factor first when you're trying to factor something. That's really always the first thing we're going to look for. Because if we can find it, it makes the rest of our job easier. Okay, everybody have that? Is that just written on your papers? Yes? Okay, let's go ahead and go then. So the first thing, as I said, we want to look for is, do we see any common factors that we can take out of all 3 of these terms? And it's not an x because we don't have an x here, right? And there are no numbers. So no, there are no common factors. And a lot of times there won't be, but that's the first thing we want to look for. So what we're going to do is multiply a times c. Now there's no a written here, but what is the a automatically? Not x. The number part, the a is the number part, and the number is 1. So we're going to do 1 times 12, which is 12. Okay, so that's step 1. Multiply those 2 together. Step 2, we want to find the factors of 12. Now, before we start writing them down, I want us to think about a couple of things. If you are finding the factors of 12, 12, you may notice, is a positive number, right? So if you're going to multiply 2 numbers together and get a positive answer, what has to be true about those 2 numbers that you're multiplying together? Let me rephrase. What has to be true about the signs of those 2 numbers that you're multiplying together? They'd have to be the same, either 2 positives or 2 negatives, right? That's our rule. If you have 2 positives multiply together, the answer is positive. If you have 2 negatives and multiply them together, the answer is positive, right? So this plus sign right here tells us we're dealing either with 2 positives or 2 negatives. Does that make sense? The next thing we want to look at, so that's looking at this sign. The next thing we want to look at is this sign right here in the middle. Because if you remember, we want these 2 numbers to add up to be 7, positive 7. And what that tells us is they both have to be positive. And here's why. because if you add two positives together, you'll get a positive, right? But what happens if you add two negatives together? You get a negative, right? Does that make sense? Multiplying, you get positives, but adding, you get a negative, and that's what we need. We need this to add up to be a positive, so that's gone. So by checking those two signs, we know the numbers we're looking for are both positive. So when I start listing factors, I don't have to worry about listing any negatives. They're both positive. Now, when I do this, I just start with, I know that 1 times 12 is 12, right? But do those two numbers add up to be 7? No, that equals 13. 2 times what equals 12? 2 times 6. Do those numbers add up to be 7? No, so that can't work. Next, I would check 3. 3 times what equals 12? 4. Do those two numbers add up to be 7? Yes, they do, right? 3 plus 4 is 7. So this is the ones we're going to use. Now let me pause there. Does everybody understand why I'm choosing 3 and 4? Because they multiply to be 12 and they add up to be positive 7. It has to work for both. Okay? So that's step 2. Find the right two factors, which we just did. Step 3 is where we break these 3 terms into 4. So here's how we do it. We just copy down the first term, x squared. And we copy down the last term, plus 12. But this middle term is the one we're going to break up. And we're going to break it up using these two numbers. So we're going to write that 7x as 3x plus 4x. Now, is everybody okay with me doing that since 3x plus 4x equals 7x? Does that make sense that would be okay? It's like if you go to somebody and you say, here's $1, can I have 4 quarters? And as long as those are equal, that's okay, right? It's the same thing here. As long as I'm replacing that 7x with something that's equal to 7x, this is okay. All right? So now, here's what we do. Now, that was step 3. Rewrite this in 4 parts. Now we're going to do our factoring by grouping. So group number 1, group number 2. What can we take out of both of these in group number 1? An x. And after we factor out that x, what's left inside the parentheses? Yep. Let me pause there for a second. Does that make sense? If we factor out an x from x squared, you have 1x left. If we factor out the x from the 3x, we have 3 left. Then we have to take out that plus sign. What can we take out of the second group? Factor out of the second group. 4, right? 4 goes into both the 4 and the 12. So 4. And when we divide by 4, what's going to be left in the first part here? X. And how about in the second part? 3. And look at that. Notice with our 2 big terms now, what is in both of them? X plus 3. So we're going to factor that out of each of them. And then what's left in the first term here? The x. And what's left in the second term? Plus 4. And so that's our factorization. Okay. And that's the process we're going to use to factor these. So the first kind of 2 steps are to get ready for step 3 to break it into 4 parts. And then we factor by grouping. Now, some of you guys may notice, or may not, and that's fine. In this case, the plus 3 and the plus 4 are exactly the same as these numbers right here. And you would be correct. They are. So actually, in this case, this is actually what I'm going to say is this is a shortcut method. If this number right here is a 1, we actually get to skip these 2 steps and go straight from here to here. Okay, but I want to show you why it worked first before we just start jumping to that. We're going to be able to, if this is a 1, we're going to be able to skip the factoring by grouping and go straight to here, which is going to save us a lot of time. Okay, but that only works And I'll say it a lot of times, that only works with our shortcut method where that x squared has a 1 in front of it. Okay. So that's the first full quadratic factoring we've done. What questions do you have before we go on to the next one? Because we've got a lot of examples. No questions yet? You're like, it's Valentine's Day. We just want to get out of here fast. So we're not asking any questions tonight. All right. So the next one, same kind of setup, right? No greatest common factor that we can take out of all three terms. And do we notice we are going to be able to use our shortcut? Because that first term coefficient is just a 1. So we like that. But our steps are going to be the same. 1 times -3 equals -3. Now last time, we had a 12 and it was positive. This time, we have a -3. So let's think this through, because this is different than last time. If we're going to multiply two numbers together and get a negative answer, what do we know about the signs of those two numbers? A couple of people at once. What's going to happen is one of them has to be negative and one has to be positive if when we multiply them together, we get a negative answer. Does that make sense? So it's got to be one of each. So that's what this one tells us. If this is a negative, I know it's got to be one positive and one negative. Does that make sense? That's our rules for multiplication. Okay. Now, we still want to look at this middle one. And this middle one, remember when we add these two numbers together, it has to be a -2 when we add them together. Here's what that tells us. If I know that I'm going to add one positive number with one negative number, and the answer is negative, does it make sense the negative one has to outweigh the positive one so that the result is a negative? Okay. Because if the positive one outweighs the negative one, the result will be positive, right? So this is what this tells us. The negative one is the bigger one. So I just circle that to remind myself the negative one has to be the bigger one. Now, when we write down our factors of -3, there aren't many options. So if the bigger one is the negative one, I'm going to put 1 with -3. Okay, so that multiplies to be -3. Does it add up to be -2? Yeah, so actually that's the one we're going to use. In fact, that's the only option because there aren't any more where the bigger one's positive, right? So we're going to use that. And again, because this is our shortcut method, we're going to go straight to this. So here's how the shortcut method works. I know I have to have an x squared there. And the only way to get the x squared is to have x times x equals x squared, right? And then I just take these numbers and put them in. +1, -3. That's the shortcut method. But again, we can only use that if this is a 1 in front of the x squared. Otherwise, we have to do the factoring by grouping. Okay, which if we can use the shortcut, do you see it is a lot faster? Okay, so there's our two factors, the x minus 1 and the x minus 3 and x plus 1. Any questions on that one? All right. Okay, first step. Do we have any common factors this time? Greatest common factor. What is it? 7. It's tempting to think 7. 7 works for 7. 7 works for 28. Unfortunately, 7 does not go into the 45. It's close, 42, right? But it's not 7. But we actually don't have any. It was not a trick question, but we want to check that every time. But 7 is not a greatest common factor. So unfortunately, that means this time we don't get to use our shortcut method, right? Because that number is not a 1. The rest of the process works the same way, though. Here's how we do it. 7 times -28. And if anybody has their calculators, I'm going to probably need some help here. What is 7 times -28? 196. Okay, negative 196. Now we're going to go through the same steps we did before. All the steps are going to be the same as the very first one we did. We look right here and we see that's a negative number. What does that tell us about the signs of the two numbers that we're looking for? You're one step ahead of me. They have to be different signs, first of all, right? So one is positive, one is negative. And he's already answering the second question. The second question, we look right here, and what does that one tell us? The negative one has to be bigger, right? Okay. So when I'm listing these, I'm not going to list any where the positive one is bigger. That'd be a waste of my time because that isn't going to work, right? So let's start listing them. And I'll just tell you this, the better you are at your math facts, the quicker you're going to get these answers. But I'm just going to show you all the listings so that you see, if you just keep going, you're going to find it. Okay. So, and you can use your calculators for this. And in fact, we're probably going to need them. So the first one I would do is 1 with negative 196. Is that going to be negative 45 when we add them together? No. Then I would go with 2. And the way you get this is you just take negative 196 and divide by 2 with your calculator. And that's going to give us, I think, negative 98. Somebody could double check me, but I think that's what it is. And does that add up to be negative 45? No. So we can check 3. What's negative 196 divided by 3? It doesn't work, does it? So 3 is not even an option. What about negative 196 divided by 4? Negative 49. And does that add up to be negative 45? Yes, that's why she said it with that tone. She's like, we found it. Positive 4 and negative 49. So these are the numbers we're going to use. Now here's where you got to be careful. I showed you the shortcut. But remember, we can't use the shortcut here, right? Because this is not just a 1. So we've got to go through that longer process. A lot of people take those and they slap them into the shortcut method. It's not right. So here's what we need to do. Remember, we have to write this. 7x squared gets written there. Minus 28 is still at the end. And then this middle term, the negative 45, gets replaced by these. So plus 4x and minus 49x. And again, the reason that's okay is because together they equal negative 45x. Does that make sense? That's why that's okay. It's not like I'm performing magic tricks up here. Okay. Then we do our factoring by grouping. And what can we take out of the first group? The first half. Yeah, just an x. The 7 and the 4 don't have anything in common, so just an x. And then what's left inside the parentheses after we take out an x from each of these? 7x plus 4 is correct. Then, as a reminder, we have to take out this negative. Whatever sign that is, you've got to take that out, positive or negative. And is there anything that divides into both of these evenly? Yeah, this time it is a 7 that goes into both of those. So we're going to factor out a 7. And it's a negative 7, right? So negative 49x divided by negative 7 leaves us with what? Positive 7x. And how about negative 28 divided by negative 7? Positive 4. Okay, now notice magic. This isn't magic. They came out to be the same, right? Again, what can we factor out of both of those? 7x plus 4. And what's going to be left in the first one? X. And what's left in the second one? Minus 7. And so those are our two factors. And here's the thing. If you did this work right here correctly, these should always match up. If you did that wrong, then this will not be right. But as long as you pick these correctly, these two factors will match up so that we can factor it out. Okay? So that's why we have to think through this so carefully, because if we do this right, the rest will work. If we don't do that right, the rest will get messed up. Okay. Questions on that one? That was the first one that had a something other than a 1 there in the front. Okay. And again, just to remind us, what we're looking at here is we've taken this and broken it down into this. If we multiplied this back out, we would get back to here. So we're doing the reverse of the distribution that we've learned previously. Okay. All right, there's our two numbers there, our factors. All right, this one, do we have any greatest common factors this time? Nope. So we're just going to go 2 times a times c, right? 2 times -6. And what is 2 times -6? Negative, say that again.
12.
-12. Okay. Now, again, what does the negative tell us about the signs of the numbers that we're looking for? One is positive and one is negative. Oops, I was supposed to leave that red. Oh, well, you'll figure it out. I try and keep them in the same colors. So we're thinking about that. Okay, so one is positive, one's negative, and then what does this one tell us? Say that again. Well, they're different. So what this one tells us is the bigger one is positive. So when we're listing them out, we're going to say the bigger one each time that we check, that's going to be the positive one. So looking at this, if I start with 1, it would have to be -1 with positive 12, right? Does that add up to be, what does this have to add up to be? Positive 1, right? So no. The next one, -2 times what? 6. Does that add up to be 1? Nope. -3 times 4. Does that add up to be positive 1? Yes. So that's the one we're going to use. Or those are the two that we're going to use. But again, this one is not the shortcut, right? That's the one danger. That's why I don't even usually want to talk about the shortcut, because a lot of people just jump into that every time. This one is not the shortcut. So we've got to do 2x squared and the -6, and then the -3x and the 4x go in the middle. And again, very repetitive, but the reason we can do that is because together they equal positive 1x. Okay, so factoring by grouping. Here's our first group and our second group. What can we take out of the first group? Just an x. And a lot of times, it's always at least an x, but a lot of times that's the only thing you can take out. What's left? 2x minus 3. Everybody okay with that? Factored out an x from each. Okay. Then remember, we have to take out this sign right here, and in this case, it's a plus sign. And then we look at the second group. What can we take out of both of those? A 2. And what's left when we factor out a 2? Correct. And again, as long as we did this right, this will work out, because what can we take out of both of these terms, big terms now? 2x minus 3. And then what's left? What's left in the first one? And the second one? Yeah, so x plus 2. It's kind of fun when it works out, doesn't it? Isn't it? Maybe not. I don't know. I'm nerdy. I'm sorry. I like math. Okay. Questions on that? Does that make sense? Okay. And the nice thing is, whether it's the shortcut method, this one, this will always work if these things are factorable. Okay, and that's the nice thing. Sometimes people learn like 6 different methods, and I'm like, yeah, I understand that. Maybe it's easier in this one case or this one case, but this will always work. So that makes this my preferred option. All right, again, looking for a greatest common factor. Do we have one? Nope. So we're going to go, and again, it's not a shortcut, right? Because we got a 2 there. So we've got to do 2 times 20. And what is 2 times 20? What is it? 40? Okay. And then we look at this 40, and we can see this is a positive 40. And if it's a positive, what does that tell us about the signs of the two numbers we're looking for? Both are positive or both are negative, right? They have the same sign. And once we know they're the same sign, then we look over here and we find out they are both what? Both negative. So when we're listing these, we're only looking for negative options. So the first one would be -1 and -40. But the problem is that doesn't add up to be -13. -2, and again, you can just divide that, but it would be -20. Does that add up to be -13? Nope. 3 will not divide evenly into 40. You can check it with your calculator, but it won't. -4 and -10. Does that add up to be -13? It's really close. It's -14, but we need -13, so that one won't work. How about -5 times -8? That's the one, right? -5 and -8 adds up to be -13. So that's the one we're going to use. And remember, this is not the shortcut. So 2x squared minus the 5x minus the 8x, and then the plus 20 at the end. And again, that's only legal because the -5x and the -8x together equal the -13x. Okay, so let's do our factoring by grouping. What can we take out of the first group here? X. And I know I said that a lot of times it's just an X. It isn't always just an X, but I don't know why. A lot of times it just works that way. There could be a number there, but it's just X in this case. And what's left after we factor out the X? 2x minus 5. Then remember, you have to factor out whatever this sign is, and in this case it's a negative. What else can we factor out besides just the negative? A 4. So dividing by a -4, -8x, dividing out a -4 leaves us with positive 2x. And here's another one. 20 divided by -4 is -5. Okay, and good news, they match up. So what can we factor out of each group? 2x minus 5. And what's left? The x and the -4. Okay. Are we getting it? Is it making sense? Okay, that's our answer. Let me see where we're at here. Looks like we've got one more before our special pattern. So let's go ahead and take a look at this one. Oh yeah, I like this one because this illustrates something that sometimes people skip. Now, oh, and I shouldn't have erased that, but again, if you know your multiplication facts and you can jump directly to, oh, I know 5 and 8 will work for this, that is totally fine. But if you're not sure, you can just go through and keep dividing one bigger, one bigger, one bigger, like I did, and eventually, if it's factorable, you should get to the group that works. Okay? So, all right, any common factors on this one? No. So what do we have to do? I'll let you guys take me through it this time. What do we have to do then? Yeah, 5 times -5, A times C. And that is -25. Okay, then if we look at the fact that this is a -25, what does that tell us about the signs of the two numbers that we're looking for? One negative and one positive. Okay. Then we know they have to add up to be positive 24. So what does that tell us? The bigger one is positive, because when you add them together, the positive one has to outweigh the negative one, right? And so when we look at this, what are the factors here that'll work? -1, positive 25. right? That adds up to be 24. That's the one that when people are trying to do their math facts, they just skip that one for some reason. Then it takes them forever. Like, I can't figure it out. It's okay. So that is our grouping there that will work. It's the very first option. And actually 25 doesn't have many options. But again, this is not the shortcut, right? We've got to rewrite this. 5x squared minus 1x plus 25x minus 5. And again, very repetitive, but the reason we can do that is because they add up to be the 24x in the middle. Okay. Factor by grouping. What can we take out of the first group? An x. And what's left? 5x minus 1. We have to take out this plus sign. Whatever's in the middle there, in this case, it's a plus sign. And what can we take out of the second group? A 5. And what's left there? Okay, a minus 1. And then 5x minus 1 can be factored out. And then what's left after we factor that out? X plus 5. I just realized I have not mentioned something. Some of you might think, how is he picking which one goes first and which one goes second when he writes those down? Like, why did he put the negative 1x first and the 25x second? It doesn't make any difference. So let me show you that it doesn't make any difference. So let's say that I had 5x squared, and I put the plus 25x first and the minus 1x second, and then minus 5. Okay? And we factor by grouping, so group the first two and the last two. What can we take out of the first group this time? A 5 and an x. And what's left? From here would be just an x, and from here it would be 5. Then remember, we have to take out the negative. And what can we take out of the second group? Yeah, you can always take out a 1, but that's it in this case. So remember, if we're dividing by negative 1, this becomes x. Negative 5 divided by negative 1 becomes plus 5. Notice again, they match up. X plus 5 can be factored out. And what's left? 5x minus 1. Now they're in reverse orders, but what do you see about these two factors? They're the same, right? It doesn't matter which one you pick first. And I realize I hadn't talked about that yet, but it's not like, oh, I have to put them in the right order. It doesn't matter. As long as you have the right two numbers, here, put them in the middle, and you can factor. So sometimes, if you switch them around, it won't make any difference. I mean, all the time, if you switch them around, it won't make any difference. So sometimes I'll switch them on purpose, and sometimes I'll just leave them where they are. Okay? Is that process making sense? Okay, that's good. Is it warm in here? No. No, I must be working on a sweat up there. All right. So we do have a couple of special patterns that I want to mention. Some of them I'm not going to spend any time on at all. But then this one right here is one that we definitely want to talk about because it's a little bit different. So this first one is a pattern called the difference of squares. And some people call it the difference of perfect squares. But when we're talking about this one, the pattern is you only have two terms that or two terms in your polynomial that you're trying to factor. And the first one is a perfect square, and so is the second one. And there's a minus sign in between it. That's why it's the difference, subtraction, of two perfect squares. And if that's the case, it always factors to be whatever the square root of the first one is, plus the square root of the second one, and then the same thing with a minus. So we're going to do some examples of that. That one I would suggest you learn because that one is a big time saver if you can recognize that. You can do it the way we were doing it, and I'll show you how to do it just in case you get scared and can't remember it all of a sudden, but you can do it the way we've been doing these ones for the last half hour or whatever. But this is a special pattern that can save us some time. The other ones are the perfect squares patterns. Honestly, I don't spend a whole lot of time on these because for me personally, by the time I would recognize that these are these patterns, I could have just factored them the way we have been factoring them the last 30 minutes or so. So this is a pattern that, again, you can memorize, but I'm not going to spend a whole lot of time on it because we can do these just like the other ones that we have already done. Okay, and that's on your, oh, that's not on your paper. So you've got to write that one down, I guess. There are those two, three. Anybody need more time to write those down? All right, let's take a look. I'm going to show you how to use the pattern first, and then I'm going to show you how you could do it with what we've already been doing for the last 30 minutes or so, okay? So the first hint that it might be this special pattern is the fact that there's only 2 terms. Because if you look at all the other ones we did, there were either 3 terms or 4 terms, right? Or there were 3 terms and we broke them up into 4 terms. But there's only 2 terms here. So that's the first hint. And the second hint is that there's a minus sign in between them. So here's where we want to think, oh, I should maybe look for that special pattern. And here's the idea. We have to be able to write it as something squared minus something else squared. We have to be able to write it as perfect squares. So I'm going to ask this one first. What squared will be 16? 4 squared. So does it make sense this piece, 4 squared, is still equal to the 16? Those are the same. And then over here for the first one, it's a little bit trickier because of the x, but what squared is going to equal 9x squared? 3x. The number part is pretty easy, right? 3 times 3 is 9. But you also need the x because x squared gives you x squared. Okay, so that's our, we have to have that in order to use the pattern. Okay. Now here's what the pattern says. Let me remind you of what the pattern says. If you've got a squared minus b squared, it factors to be a plus b times a minus b, right? That's what the pattern says if you look back on the other side of your paper. So here's what that means, and I'm going to try and use 2 different colors to kind of emphasize. The 3x is the a in the pattern. Does that make sense? And the 4 is the b in the pattern. So when we write this out, that's what I'm going to follow, okay? So equals, and I know I'm going to have these 2 parentheses here. The first one is going to have a plus in between. The second one's going to have a minus in between. So first, I should have in the parentheses, in the beginning of each one, I should have the a value, which is 3x. Okay. And second, in each of those parentheses, I should have the b part, which is 4. And that's it. We're done. So if you can learn and recognize that pattern, it takes that amount of time. It's very quick. Okay. Now, if the pattern isn't coming to your mind and you don't remember it, well, before I go on, are any questions on that? Okay. So if the pattern's not coming to your mind, I'm going to show you we can, right with the dead marker, we can do it the same way we were doing the other ones. So the trick is here, there's a plus 0x in the middle that's invisible because it's 0, right? So the 9 is the a part, and negative 16 is the c part. So we would have to multiply 9 times negative 16, which is negative 144. And then the rest is exactly the same as what we did before. We look at the fact that it's negative, and what does that tell us about the 2 numbers that we're looking for? Or the signs of the 2 numbers we're looking for? Correct. One is positive and one is negative. And then here's the part that's a little tricky or different. The middle term is a 0, which tells us immediately when we add them together, we get 0. They have to be the same number, but one's positive, one's negative, right? Well, what number times itself, one positive, one negative, will equal 144? What? Oh, I thought you said something. Anybody know? And this is where your multiplication facts come into play every once in a while. But it's 12 and negative 12 multiplied together equal negative 144. Right? And do you see how they add together to be 0? Because they're opposites. So you're looking for opposites that will multiply together to be negative 144. So if we rewrite this, it says 9x squared plus 12x minus 12x minus 16. And then we do our factoring by grouping. What can we take out of the first group this time? A 3 and an x. And when we divide out the 3x, what's going to be left here in these first two terms? Here we're going to have 3x. And here we're going to have plus 4. Then remember, we have to factor out the negative. And what else can we take out of the second group? The 4. And then if we divide out a negative 4 from here, we get positive 3x. And divide this one by a negative 4, and we get plus 4. And notice we can factor out 3x plus 4. And what do we have left? 3x minus 4. So we can still do it with that little alteration. Think of a 0 in the middle. But isn't this a lot quicker? So if you can learn this and use it, that's what I would suggest. But if you get stuck and you can't remember it, you can still do it the other way. Okay? So just to show you that, this one we're going to, and again, order, you write them in. Come on here. Battery just die. Here we go. The order you write them in doesn't make a difference. So just because I have the positive one first and the negative here, that's the same thing. Okay. All right. Looking at this one. Man, this has only 2 terms, but it does not look like perfect squares, does it? Anybody think of any perfect squares for 12 or 75? Nope. But what should we always look for first? Greatest common factor. Do we have a greatest common factor here? Yeah, what is it? 3, correct. 3 goes into both of these. And when we factor out a 3, what's left in the first one? 4 and the m squared, and then minus what's left in the second one? 25. Oh, they look a lot better now, don't they? 4 and 25. So I'm going to leave this 3 out here because it can't disappear. And I'm going to put brackets here because I'm going to put parentheses. Because we need to have that pattern, right? 2 things that are perfect squares. What squared equals the 25? 5. And then what squared equals the 4m squared? 2m. Okay? Then we just have to follow our pattern. Now the 3 is still here, but the pattern said the first thing plus the second thing. So 2m plus 5. And then it also said the first thing minus the second thing, 2m minus 5. That makes sense? So again, it's a big time saver if you can learn that difference of squares pattern. Okay, but again, it only works if they're perfect squares and if there's a minus in between them. Has to be that setup, otherwise you can't use it. Questions on that one? But always look for that greatest common factor too. Okay. All right. Now we've done all this factoring stuff, and the reason that we do factoring a lot of times is to try and solve equations. So here's how we would use factoring to solve an equation. So the first thing again is are there any greatest common factors that we can factor out of all 3 of these? No. So we've got to go with 4 times negative 15, which is negative 60. And we look at this negative 60 and we say, uh-oh, it's negative. What does that tell us about the signs of the numbers we're looking for? One's negative, one's positive. Correct. Say it with confidence. It's okay. Then we look at this one, and there's a plus sign in the middle. So when they add it together, they equal a positive. What does that tell us? Bigger number is positive. Yes. Okay, because when you add them together, the positive one outweighs the negative one to leave a positive result. So when we start doing these, we're going to pick positive ones that are bigger. So negative 1 with positive 60, that obviously doesn't add up to be 4. Negative 2 with 30, nope. Negative 3 with 10. Wait, what did I just do? 20, sorry. Nope. Negative 4 with 15, nope. Negative 5 with 12, no. Negative 6 with 10, whew, finally got it. 60 has a lot of factors that go into it. But this is the one we're going to use, right? Adds up to be 4. So what do we do with that negative 6 and that 10? We have to put them in the middle, right? So this is not the shortcut method. 4x squared minus 6x plus 10x minus 15 equals 0. And then we're going to factor by grouping. So group and group. What can we take out of the first group this time? 2x. And after we factor out the 2x, what's left for these two terms? 2x minus 3. Is everybody okay with that? And then remember, we have to use this middle sign whenever it is. It's a plus in this case. And then what else can we take out of the second half? The second group, 5. And what's left when we factor out the 5? 2x minus, careful, 3. Okay, and then the 2x minus 3's match up, which they should, so we can factor that out. And then what's left for the rest of it? 2x plus 5. Okay, now we have done the factoring, but notice this question was different, right? This is the first one we've seen like this tonight. This question is an equation, right? It equals 0. So now we're going to use a property that you learned way, way, way back, probably in like 2nd or 3rd grade. It's a property that you all like because it made the problems really easy, okay? If I have a number and I multiply by 0, what is the answer? 0, right? We all love that property, right? I knew the answer right away because it was going to be a 0. Well, here's the deal. If I have a 2x minus 3 and I multiply by 0, does that make sense? The answer will be 0. So one option here for us is 2x plus 5 equal to 0 will give us a solution. On the other hand, if I take this 2x plus 5 and multiply by 0, won't that also be 0? So the other option is if 2x minus 3 equals 0, it's going to make this true. So let me repeat that. If 2x minus 3 is 0, it doesn't matter what this is, the answer will be 0. Right? Or if 2x plus 5 is 0, it doesn't matter what this is, the answer will be 0. Does that make sense? Because if it doesn't matter if I have 100,000 times 0, it's still going to be 0. Or negative 2 million times 0 is still going to be 0. So if this one is 0, that'll make it true. If this is 0, that'll make it true. And that's what we're looking for. What are the numbers that will make this true? That's what we're doing when we solve an equation. Trying to figure out what will make it true. So we've got these two little equations now that we want to solve. What do we do with this first one? Add 3. So 2x equals 3. And then what else do we have to do? Divide by 2. That's a 2. And we have x equals 3/2. That is one of our answers. Remember how with the absolute value, 2 answers? You get answers with quadratics a lot of time. Technically all the time, but we're not going to get there yet. What do we have to do on this one to solve? Subtract 5. And again, we cancel. And we get 2x equals -5. And what else do we have to do? Divide by 2. And we get x equals -5/2. So those are the two answers that we get. And again, on the computer, you just put them in with commas in between them, no parentheses, no nothing else. Just put 3/2, comma, -5/2, because most of the time the x equals is in the front of the box, so you don't have to worry about that part. Okay, does that make sense on that one? So here's what I want to say. Most of the problems on your homework are just factoring, like what we've done already. But I do have a few like this, because this is really why we do the factoring, is to get to stuff like this where we can solve these things. So there are a few like this that are at the end. I think there's maybe 2 or whatever. But any questions on that before we do our last example, I think? Okay. So yeah, we get our 2 answers there, and just I list them this way, but in the computer, they've already got it there. You just put commas in between them. All right, here's our last one for the evening. So again, our first step is to look for greatest common factors. Do we have any this time? Nope, the 29 messes us up, right? So we're going to take 5 times 20, and 5 times 20 is 100. And notice it is a positive 100. So what does that tell us about the signs of the numbers we're looking for? Both positive or both negative? Okay, that's our 2 options. Then we look right here, and since they have to add up to be positive 29, what does that tell us? They're both positive. Anybody know the answer to that one without listing them all out? This is, like I said, this is where sometimes your math facts come into play. Yeah, quarters, right? 4 times 25 is 100. 4 quarters is $1. And that's the one that works for us, 4 and 25. So again, unfortunately, there's no shortcut here. We just have to plug them in. 5x squared plus 4x plus 25x plus 20. And again, this one is an equation, so it still equals 0. And again, I want to pause here because most of your homework questions are just factoring. But don't do the extra equals 0 and try and solve them if it's not an equation, right? If it doesn't say equals 0, you're going to be done after you factor. I just don't want you doing extra work. I mean, go ahead, do extra work, but it's not, you don't want to have to do the extra work. So we're going to factor by grouping here. And what can we factor out of the first group? X. And what's left? Correct, 5x plus 4. Then remember, we have to take out the plus sign. And what else can we take out of that second group? 5. And what's going to be left after we divide out the 5? 5x plus 4. And again, if we did our work correctly over here, these should match up. So it shouldn't be surprising that they work. So we can take out the 5x plus 4, and then what's left? X plus 5. Okay. Now, when you get to this point and you've got the factors, the easy, quick way to do this, you don't have to go through all the explanation of thinking back to what happens if this and this. This is going to work if either one is 0. So we just take each factor, 5x plus 4, and set it equal to 0. Because we know if either one is a 0, it will make that statement true. So what do we have to do for this first one here? 5x plus 4. Yep, subtract 4. And then we're going to have 5x equals -4. And what else do we need to do? Divide by 5. So x equals -4/5. That's one of our answers. And then the other one is much easier. What do we have to do over here? Subtract 5, and that's it, because then it's just x equals -5, and we're done. And if you wanted to check your answer, if you took this -5 or this -4/5 and plugged it in for all the x's and then simplified it on your calculator, you would get 0 for both of them. I mean, assuming we did all our work right, but we did. So, okay. So that is the end of that. And you got 10 problems there. Like I said, most of them are factoring. There's probably a couple equations at the end. So, but again, don't go through the solving part if it's not an equation. And the directions will say factor this, or it'll say solve this. That's the difference, because you can't solve it if there's no equation. Okay? So how do we feel about the factoring? Now, the factoring assignment is not due until, this is the 14th, 21st, 28th. Okay? Because coming up this week, I want you to focus on 2.5 and your test, right? And reviewing for your test. So 2.5 and the test, 2.5 by Monday, test on Tuesday. And then this one will unless you want to do it, that's fine. But I'm saying don't stress out about this. I'd rather you work on the test. But this one won't be due until the 28th. And then also we'll have 2 lessons. We'll have 1 lesson week for the test, and we'll also be on the 28th. Okay, so not the 17 lessons that we have because of the snow days and everything like that.